Hi there, this is Matt Heffernan, and welcome back to my channel. Today I'm going to be talking about the new release version. It's an alpha release. We're not really a beta release yet, but an alpha release of my new game, Alice in Wonderland, for the Atari 2600. And this is the first Atari 2600 game that I've ever created, and it's still very much a work in progress. And what we're going to see is a little bit of how it works. Right now I've got two levels implemented. I don't have any sound yet, so I'm just going to be talking about what's going on. And let's just get right into it. Let's see what this game looks like. So for my purposes, I'm a Linux type person, as you know. If you are a subscriber to my channel, and if you're not, please do go back to my channel, subscribe, go back and look at the previous videos. My last video was an earlier demo of this game, and we've got quite a bit more going on now. So let me go right into what this game looks like right now. And let me get this out of that. All right, now we're into actual Stella. So Stella is a great tool for both just playing games on multiple platforms, especially Linux, and really for developing. It's invaluable with a built-in debugger and all sorts of awesome features. So let me get this up to full screen, and we can see now. If you hadn't seen the previous video, and only saw 2 videos ago when I first introduced it, this was the not the original title screen. This, of course, is a more simplified title screen to make room for the level 1, which if you hit the joystick button, boom, you're right in. And as you've seen before, there's a white rabbit, and here I'm trying to chase after him, but of course he moves faster. So here I can collect some bonus items, though, and get some score building up. So I can just jump over here, nothing happens, but I jump and I get this. And then once I get to the end, boom, I'm down the rabbit hole. And now you see, oh, look, oh, that didn't work out. Good, did it? So as you saw there was a cake, one of those little eat me cakes, kind of like in the previous level. You had the little drink me bottles here that Alice does actually collect in the original novel. And here they're just used as bonus items. They don't actually make you grow or shrink, but you can use them to accumulate and try to do better. But as you can see here, these cakes are very close to the walls of the rabbit hole, and if you hit the wall, well, poor little Alice dies. It's very tragic, but you know, it's the Victorian era, and children dying is just part of life, and especially part of the horrible, scary children's literature of the time. So just by hitting the joystick button, boom, you're back to the beginning of the level, and you can try it again. Let me see if I can get it this time. No, those are hard to get. I think one time I managed to do this perfectly to get all the bonus items. Oh, and I died again. So yeah, I tried to make this still difficult. It still requires some good twitch reflexes to be able to get through perfectly. But of course, you don't need to get these cakes. These are just to get those extra 25 points each. Part of the fun is trying to see how much you can get, but the bonus item you do need to get, which comes under this ledge, is that umbrella, and I did get it. And then, nice slow descent using that umbrella, and I get to the bottom of the rabbit hole safe and sound, and then I can walk off into the as yet unimplemented level 3. So let's take another look here. Let me reset so I can show otherwise how this can go. Now, of course, I can just go through here. I don't need to get these bottles. I can just run right through if I am just trying to, you know, speed run the game. But jumping doesn't actually slow you down. I don't have any fancy physics engines going on here. But now let's say, oh, well, this is pretty easy. You know, you don't try to go for the bonus items. You already get the 100 points just for doing nothing more than leaving that first level and going all the way to the end. But here, if I fail to get the umbrella, because it is kind of tricky, it's like, oh no, I didn't get it. Oops, what's going to happen? Oh, I, again, just plummet to my death instead of getting run over. But just like before, I hit that joystick button, and I get another chance at life. Let me see here. Ooh, if I can get all 4 of the cakes. This really is cake or death. There's no in between. If you're a fan of Eddie Izzard, you know exactly what I'm talking about. All right, and boom. All right, see, got all the items. It is possible. It's not easy. I have not done it many times. Now, when I get down to the bottom here, I'm no longer in control. It just automatically walks off, doesn't force you to actually walk off. And then that's it. So I got that perfect 500 points for level 1. Unfortunately, did not do it without dying. So let me quit out of the emulator here, and let's get back to the presentation. So let's talk a little bit about what we just saw. Now, if you know anything about homebrew for the 2600 or just development in general, you know it's not easy. If you go back and look at my very first Atari 2600 video, which is the Hello World for the 2600, I show how to make a playfield bitmap like this title screen here. Is actually very difficult and requires, even for that, having to do beam racing, which is just the joy and the nemesis of any developer is just trying to get things that happen just in time for that scan beam of old NTSC tube television set. So let's take a look here. Now, how do I make the 2600 do this game? Well, first of all, I need a lot more than the standard 4K ROM. I am building this to a 32K ROM. I'll show you how I do that. So that first bank of the ROM, that first 4K, is just that title screen and this level 1. But I can make level 1 pretty small because that title screen does take up a lot of ROM space to have all that graphics in the playfield. But first I have the score, which is a 16-line dynamic playfield with some margin on the top and the bottom. You can, in fact, start putting this score into the overscan above the after the vertical blank. I'm sorry, in the vertical blank section before the main part of the picture. You could start it in there, and you've got that first 15 black lines that you could just shove up into there if you want to have more space for graphics on the bottom. But that's my implementation. I like having it a bit below because, especially with older TVs, a lot of times that the upper ends and the sides tend to get cut off. You don't even get close to the overscan of those old TVs. In fact, you get quite a bit more cut off by those old CRT bezels. So anyway, it's a dynamic playfield for that score. It's changing the playfield, and it is a repeated playfield that changes midstream, so that what we see here is on the first half of the pass, there's nothing in the 0 register. This is the 1 register. This is the 2 register, and then here we hit the 0 register again for the playfield, and by then we have to, in between the blank part of it here and before we get to the end of the 2 register, we fill that 0 register with whatever the digit is from the score, and the score is just stored as binary coded decimal, and I just keep adding to that. I don't do any conversion. There's no point in doing that. I'm just adding values to a BCD value that is 5 nibbles wide. That's it. Don't need to get any more sophisticated than that. And I don't plan on the scores exceeding 5 digits, so again, save a little time and by only having to calculate and lay out what those numbers are going to be for just those 5 digits. Then, for simplicity's sake, to make it fit within that limited amount of ROM, I just repeat this tree graphic that is built also with a playfield. And you'll notice here that I have the backgrounds are going from blue to green, and then to this sort of dusty yellow, and then back to green, and then the only thing in the foregrounds for the playfield are these trees, where it's green down to here, and then the rest is brown, and then I don't have anything actually in the playfield underneath there. I'm just changing the background color. And then here, these Drink Me bottles are actually three independent sprites that don't happen to move, but you have the missile for player 0, the missile for player 1, and the ball over here. And in fact, you'll notice if you sort of jump the gun, literally, and have Alice jump before she hits that first bottle, you will, or if you miss that first bottle and try jumping after other ones, you will see the bottom part of that bottle turn yellow because it actually shares the color with Alice sprite. So I don't want to make the top of Alice's head purple. Instead, to have those sprites overlap, I choose to make the bottom of this bottle turn yellow. And it also kind of helps, it clues in the player so that if they hit that button before they try moving, in case they thought they could shoot the bunny or something, that they would see that first bottle flash yellow on the bottom. It's like, oh, maybe that's something I need to get, and it will. Get some 10 points. It's not much. There is a 0 chance of dying. These are only bonus points, just to sort of introduce you to the concept that, oh, hey, when you see these little purple things, the bottles and the cakes, that's something you want to get to accumulate some extra points. And then, of course, Alice is player 0, the player 0 sprite. And again, she's just yellow on top, then a bit of white, then blue, then white, and then brown at the bottom. And that's it. Of course, like with all these Atari sprites, on a single line, you can't really have more than one color. And so that's how we do Alice. Same thing with the rabbit. The rabbit is player 1. And it's white on top with some red, some dark gold, and for the watch and the waistband, and then of course white on the bottom with his little bunny tail. And as he hops off, he still looks at the bunny. They got 2 frames that goes between from on the ground hopping up, just like Alice has 1 frame of standing still and 1 frame walking, where you can see 2 legs. Very simple animation. And then once the bunny gets to the end here, the bunny disappears, and it actually doesn't go away. It stays there as a dark yellow collision switch, just a plain line that once you move Alice to collide with the remnant of that rabbit, where it's just a collision switch, it will then move you, jump you over to level 2. And so let's take a look at how level 2 is done. Now, I'll say right now, you should probably not do a vertical scrolling game on the Atari 2600 unless you want to go through a lot of trouble and chew up a lot of RAM. Or maybe if you're a super genius with this sort of thing, you know how to do this more efficiently. But I had a hell of a time making this work as well as it does. And as you can see, it's still not 100%. There's a little bit of glitchiness, especially once you transition from the 2 phases of level 2. The first phase is when Alice is falling, and she is always up at these 16 scan lines up here. She is falling with her arms flailing, and she's always up here, but then the actual terrain of the caves moves up and down and then reveals the little bonus items. But then once she gets down the bottom, you can see that it very obviously gets a lot simplified, because then we're rendering the sprite as it descends down to the ground, either with or without the umbrella. Without the umbrella, she slams down twice as fast and then embeds herself in the bottom, and then that's game over for poor Alice. But if she gets the umbrella, she just floats gently down and she's okay. But you can see here the terrain is simple, it's not jagged, it's nice and smooth, and that's just to make it easy to be able to detect where to place Alice and then just get her down easily. And then we can see also when we get down to here, player 1 becomes quote-unquote visible again, but as a black sprite on top of a black background, just so that when Alice starts walking over there, and again, that's automatic, you don't have to actually move the joystick, but just to prevent us from having to do some sort of long-term timing. Of course, this is long-term, where we're talking about a couple seconds for Alice to walk over there. And the thing is that we don't know where Alice is going to end up, because it's basically once you got past the end of the terrain, wherever your controller, with your joystick, wherever you left Alice at the end of that, once you relinquish control, she stays at that same horizontal position and then just falls straight down from there. And so I don't know necessarily how many cycles it's going to take for her to walk off. So instead, I just have, just like in the first level, I make player 1 a collision switch, and then once she collides with it, then we move on. And currently that just goes to that blank level where all we have is a score and a black background. So let's take a quick look at the code. I'm not going to get too deep down in it, but maybe at some point I'll take a longer look. But here we can see the main assembly language source file, just alice.asm, and you can see here in my build script I am using CL65, which is the easy compiler, assembler, linker tool that comes with this CC65. And I am specifying the type of platform is Atari 2600. But you'll notice here I have this -C, which you don't usually see for other platforms, where I'm specifying a special configuration, because the only configuration that CC65 supports natively is that the standard 4K ROM. And if you want to do a 4K ROM game, you're all set. You don't need to create your own special configuration file. But for the purposes of what I'm trying to do, which is a series of mini games, it's just no way it's going to fit, especially something as complicated as doing vertical scrolling. It just, you take up pretty much all the space. You could do a 4K game that's just all vertical scrolling and then doing different variations of that. But if you're going to have multiple styles of gameplay in one game, you really need more space. So luckily there's a 32K standard, so there's 8 different 4K RAM banks that you can switch between, and I'll show you how I do that. But anyway, so alice.bin is the output, and then that output can be put into pretty much any emulator. I actually tried this web-based one that's a JavaScript implementation of the Atari 2600, and it worked great. It worked exactly as it did on Stella, which was nice. And then here I put out a listing, which is really also very nice, where when you're using Stella, you can look at the disassembly within Stella and match that up with that listing file that CL65 creates for you. And then I just put in this one assembly language file, but I have a whole lot of different source files. Of course, there is Atari2600.inc. This is a file that comes with a CC65, and it basically has all the registers, all the TIA registers and the Riot registers are all incorporated into that. And what's nice is when you reference those, like if I scroll down here to say VBlank, VSync, WSync, all color luminance background, color luminance playfield, all of these registers, it looks exactly the same in the disassembly on Stella because it uses these same standard names that you find here in this Atari2600.inc. And then you don't have to define it yourself. You don't even have to put it in your repo. It's already there, which is nice. And then I created a bunch of other include files. I created a bank.include to handle banking. You'll notice here at the top of my code, I have 2 jump starts and then a bit on this bank 1. Well, what is bank 1? Well, bank 1 is a magic address that is in the 32K ROM, banked ROMs that Atari made back in the 80s. They did not have these in the 70s, so it would only be games from the 80s that would actually have these. And actually into the 90s, because Atari kept making games for the 2600 into the 90s. As crazy as that may sound, after the Sega Genesis came out, Atari was still making 2600 games. So it's a little crazy, but anyway, you have these magic memory addresses that all you have to do is just read them. You don't even have to write to them. You're just reading them from the ROM, and the act of that reading switches the ROM bank. And as you recall, the Atari 2600 doesn't use a proper 6502. It uses this scaled down version that only has 13-bit addressing. So whether it's a 1000 hex or 3000 hex, it can't tell the difference between that. So we can see here when I access that bank 1, what it does is it takes me to over here is where I define the ROM for bank 1, and I line it up so that after it executes that bit bank 1, it's going to be at this address right here, where it's like start bank 1. And then also I have the reset vector set up here, so if you reset while you're in bank 1, it will do that bank 0 read, which will bring you back to here. So then after you're coming off of this instruction, you're going to be here at this second jump start, which is why you have the 2 jump starts here in the main bank. And so that's how you do this banking, is that you know that the program counter is going to update normally, but then the ROM is going to change underneath you. And what's nice is that you can still use these full 16-bit addresses for the sake of your own sanity within your code, and then it all comes out in the wash. And what's nice is that the Stella debugger also recognizes these 16-bit addresses and understands that you are switching between those banks. And for this program, I've built it so that it automatically recognizes in Stella that you are using an Atari 32K ROM image. And so the way I accomplish it is, you remember here in the build script, I call out this custom configuration file, and here it is. And you can go ahead and use this yourself. It works great. As far as I can tell, there's no problems with it. I had to build it myself, which was a bit of an education. And here you can see it's I have to create all these different segments for all different 8 ROM banks, and so they're called out down here. And then the vectors, so that what we can do is when we get to the end of that code, end of the code for each bank, we have those 6 bytes of vectors for NMI reset and IRQ. Of course, only the reset ever actually gets used. There are no interrupts in the Atari 2600 unless you are using some whacked out alternate cartridge that has different CPUs running in it. But there are no hardware interrupts on the main board. And only thing is that you can go to sleep and wake up by doing a WSync when the next scan line comes, and that's it. that's the only way that the hardware actually changes what happens with the execution of the CPU. So there we have that, and you can see here at the top I include these custom includes. So you've seen the bank. I have one include for all my RAM variables. So far I'm up to A6. Of course you can go from 80 to FF for the different RAM locations that you have access to. So I've got plenty of space for defining new ones, but the nice thing is as you go from level to level, you can reuse here. So like this, I don't have the ball or missiles in level 1, so instead I've sort of repurposed them in level 1 for these flags for showing whether I'm hiding to hide the cakes or the umbrella. Once you've grabbed them, they don't show up anymore. They disappear like you'd expect them to. And then also for the hide umbrella, it's another flag to say, oh yeah, I have the umbrella. So once I get to the bottom, I change to the umbrella sprite and float down gently instead of dying at the end. So anyway, that's how the RAM is set. I have another include file for the sprites. So like the side sprites I use in both the first 2 banks. So I'm able to just create a macro for that, and then I just call that out, and then wherever it makes sense in each of those banks, I go ahead and create that. Generally what I have to do with any of these sprite banks is make sure that they all stay on the same page, just to make the timing work. This is generally not a concern if you're dealing with something like a Commodore 64 or Commander X16, where you have a bit more leeway. It really makes a difference when you're trying to race the beam to make sure that those sprites are that when you're indexing into these graphics parts of the ROM, that it's not taking you extra clock cycles to get through it because you got to jump a page. So all the many wonderful things. But yeah, so anyway, at the bottom in this first bank, we can see here I go right into the title screen, where you can see here this is Alice in Wonderland, and I used this playfield, this macro to define a playfield line, and added a whole bunch of awesome pre-processing stuff so that you can call PF line with a number. So how many lines you want to have of the playfield in this arrangement. If it's multiple lines, that makes the code a lot simpler. And then if you want to have the left and right hand sides different, if the right hand side is the same as the left hand side, whether it's reflected or repeated, it doesn't matter. If you leave those off, then it can consolidate the code more, which is how I still can use this macro later on, once I get down to level 1 to draw the trees. I don't have to call all of those arguments. I'm just saying, all right, PF0 is always 0, there's nothing there, and then PF1 and 2 are going to be the same thing on both sides. So it makes the unraveling of these macros to be a lot less code. And then I get down here, and then in my overscan area is where I'm checking all the collisions. And here, this register here is where I check the collision between player 1 and player 0. And if that collision happens, it's like, oh, you've got the end of the score. And so I add the 100 points to your score, and then I do the jump to BOB1. And BOB1 brings us back up to the top of this ROM. And as we've seen before, it does a read on bank 1, and that shoots us over. It switches the bank, and then we're right under here. So that bit bank 1 happened where those 3 no-ops take place. This for the opcode, and these 2 for the address. And then here, this is where the program counter will be when we switch, and then it will do that jump to start bank 1, and here it is. And then this ginormous amount of code that maybe someday I'll go over in detail, but basically to make the timing work, I had to do it a bunch of different ways. And at the end of it, I don't have a whole lot of space left for anything else, but I do have space in both of these banks to add music and sound effects for both these levels. So that's probably going to be, before I get to implementing level 3, I'm going to start folding in some of the sound stuff to make it a bit more interesting. And anyway, once we're down here, you can see here I do that same sort of collision check as we did at the end of level 1. And if that happens, I add 200 to the score, and then jump from bank 1 to bank 2. And that's when I get up to here and say, yes, now let's read from bank 2. And then I switch to my bank 2. And you can see the pattern. This sort of header part of the ROM has to expand to be able to have these jump tables work correctly. So now here I can go back to bank 1. So here, this jump B2, B1, this is the exact same address as it was here in bank 0. And you could, in theory, go back to bank 1 from bank 2. I don't anticipate necessarily doing that, but it is supported. Because whether I put no ops there or whether I put the actual read instruction, do that bit bank 1, it doesn't matter. It's the same amount of ROM taken up. So might as well make it so that, who knows, maybe an Easter egg to send you back down the rabbit hole and start building up some more of those bonus points. Who knows what's going to happen? I don't even know what level 3 is going to even be, but I do know I can jump to start bank 2. I do those macros for the digit graphics right there again. And of course, these are always going to be in a different spot in each ROM bank, so I'm redoing that every time. And then here, once I get to the end of my vertical blank, I do that score macro, and here it is. And this is all the code that it takes to do the conversion from BCD to a set of 5 different scan lines for all 3 playfield registers. So you get 15 different bytes to store in RAM what that's going to be, and then it goes ahead and renders it as playfield, and then it gets out. And you can see here, unfortunately, you got to take up a lot of no-ops to do that, just in strategic places. And but then it works, and then it works consistently from level to level. And like I said, you could push that score up into the vertical blank if you want to have a little more space. But for right now, I'm starting it from that top, so we get that 7-line gap at the top, which I think is, again, if I hope somebody does play this at some point on a real TV, and then you can see what it actually looks like. And I'll be very curious to see that, because personally, I don't actually own an Atari 2600, not even a broken one. I've just been doing this with emulation. Never actually owned one myself. I went from the Vectrex straight to Nintendo. and never actually had my own Atari 2600. But of course, I had a lot of friends and family that had them, and I did spend a lot of time playing a lot of those games. So I'm pretty familiar with it, but it's nice to go back, challenge myself to create these crazy games, and try to create something that I think is going a bit beyond what people would have expected from an Atari 2600 game at the time. So again, I hope you like this, and I hope you go and check out my YouTube channel, see some of the other videos, see some of the previous videos in this series of building this game and the Hello World that I have. Of course, you can subscribe. Please like and comment on this video if you have more ideas about what these later levels are going to look like. I do appreciate that. Of course, click on these bells right here. These bells tell you when I got new stuff coming up, so go ahead and check it out. And of course, you can also check out my new website, slithygames.com, and you can stay up to date. You can download the free games. It has links to everything I have on GitHub. Eventually, this Alice game will be one of those free and open source games. I will not be having any commercial licensing for it, but I do plan on manufacturing cartridges, and that will help, of course. My first commercial game will be Cavi's Quest for the Commander X16, which of course is still underway, and I've got a team of folks helping me with that, and I hope to do a new demo of that pretty soon as well. So please come on back, subscribe, like, comment, ring the bell, do all that stuff, and I will talk to you again later. Bye-bye.